it requires multiple aircraft to be synchronized so closely together they're effectively flying as a single aircraft. We've seen it's commonplace now to see fireworks drones, and people think of that as aircraft moving together in a synchronized fashion. But it's really the difference between a group of people walking across a dance floor as a group versus two dancers dancing.
Well, today on the Unicorns, we're talking to two engineers who've built one of Australia's most advanced drone companies, Freespace Operations. Ken King and Leonard Hall have cracked what the industry used to call the Holy Grail, getting multiple drones to work together to lift heavy loads. Their technology, called cooperative lift, means several drones can now carry up to 100 kilograms in perfect sync. It's a world first that's already landed them defense contracts across the Indo-Pacific. We'll talk about how they did it, why it matters for Australia's sovereign defense capability, and how they ended up building flying robots that are replacing helicopters. Ken and Leonard, welcome to the program.
Thank you very
Thank you
much.
for having us.
Okay, take me back to the beginning. How did two engineers end up building one of the world's leading heavy lift drone companies?
Well, who wants to go first, Leonard?
Yeah.
Me? All right, I'll open my mouth. So you can probably tell I'm Irish originally. I emigrated to Australia in 2009, GFC baby, and I was working in the construction industry both before I came over here and also when I arrived in Australia. And I started seeing drones just appear on the scene around 2012 and just kept an eye on them, started building them. And before I know it, I was involved in the startup scene in Melbourne, for drones and small space systems, small satellites. And through those connections, I came across Leonard at Avalon Air Show. We were sort of collaborating together on various small projects that ultimately never went anywhere. But from that interaction, from us working together, we formed a very good working rapport and understanding of each other, and it led to opportunities that eventually became Freespace Operations.
Yeah, and I've been playing in the drone space as a hobby for a long time, and that had turned into supporting industries around the world building these things. And I ended up helping Ken build a project, and we sort of started to get the feeling it might go somewhere. And we felt that out until we had the confidence that no, we actually really did have something worth pursuing, and that's where we sort of started the company. But before that, I was working as a electronic warfare specialist, so RF radar and that sort of stuff for defense. So this sort of turned into too good an opportunity to miss.
Yeah. And the rest, as they say, is history. The magic happened.
Well, a lot more work underlied that magic and that history, but times went very quick since then.
So, in simple terms, what exactly is cooperative lift, and why has it been such a tough nut to crack for the drone industry?
So it's one of those nuts that's so tough to crack, but I don't think people have really even considered trying seriously. It requires multiple aircraft to be synchronized so closely together they're effectively flying as a single aircraft. We've seen it's commonplace now to see fireworks drones, and people think of that as aircraft moving together in a synchronized fashion. But it's really the difference between a group of people walking across a dance floor as a group versus two dancers dancing. The level of coupling between the control needs to be at such a low level that that just hasn't been practical to even try and achieve until recently.
I think you're
It's been a 5-year process just to get all the small pieces in place to even make it possible to attempt.
And so, what does this allow your aircraft to do that helicopters or other drones can't do?
So fundamentally, when we're talking about cooperative lift, we're taking an aircraft that's capable of lifting 25 kilos on its own, and is extremely useful, robust, well proven, cost effective at that weight category, and allowing it to do something of a that previously you'd need a manned helicopter to do, and so it allows us to bridge that gap because we don't often need to do that sort of weight. So it's very hard to justify in building a capability to do that when it only needs to be done so rarely. Because if you're doing it all the time, then you're probably using manned assets, or it's simply too dangerous to do with manned assets. So it allows these cheap, easily used, highly robust, very mature aircraft to be applied in a dramatically scaled up fashion. There aren't many aircraft that all of a sudden you can reuse them on 4 times their payload.
Hmm.
yeah. Well, it's very important as well to note that the aircraft, which is based on our flagship product, the Callisto 50, it has a maximum takeoff weight of 52 kilograms and 26 kilos payload. So that's where we get 100 kilos from, 4 times 26, essentially. Um, the licensing structure is already in place with CASA and other aviation jurisdictions around the world, or regulatory framework. So there's already the licensing, the training, the rule sets, the like everything is sort of well known at this point now, and it's well understood. So, for example, CASA has 150 kilogram maximum takeoff weight. So that would be, if you were to scale the aircraft up, you would have to stay under 150 kilograms anyway to fly within the normal rule sets, and that might limit your payload to, let's say, 70, 75 kilos, something of that range. So you have this fundamental limit anyway with the regulatory body rule sets in many jurisdictions, and this allows us to leverage more smaller aircraft, which keep the same risk profile essentially, and do more with them.
And so, why are you doing this? What problem are you solving, and what is some of the payload that you have actually carried? Curious to know how you both thought, you know what, there's a real market in this. We should give this a crack.
Well, it's our clients are always looking to do more with less. Like ideally, our clients would like to be able to lift 100 kilos with a 250-gram aircraft, and so there's always that pressure to be able to do more of what a manned helicopter could do, but without increasing the risk profile. And so that upward pressure sort of look motivates you to look for engineering solutions. And so when it comes to our ship to ship logistics, for example, there's been a study done recently in the US where 90% of payloads that are carried from ship to ship are under 25 kilos, but they have to spool up in a very large manned asset to actually do that work with all the associated risk, costs, and maintenance. A Callisto, a ship-to-ship logistics operated user Callisto can do 90% of that work. That last 10%, you still need to spool up a helicopter. Now we're getting to that 1% can't be done by a fleet of Callistos. And it's really about just, pushing what we're capable of doing all the way to the limit.
And can you give me an example of what you're actually carrying or what you can carry?
Well, this is still very much an emerging technology and capability. So the I can't tell you what's in the boxes that Navy need to move from ship to ship, but it's
It's not an
not.
emergency six-pack on a Friday night, is
That's right.
it?
But for some of our industrial partners, we it makes a big difference for paralying stringing, for example, if when they have to do a particularly long string. We currently hold the world record for the longest string with a single aircraft, but now we're able to multiply that pulling force by a factor of two very conveniently, and up to a factor of maybe three or four. Um, so when they would otherwise need to bring in a helicopter to do that heavy string, or that particularly long string, they can use assets that they've already got on the ground.
Yeah.
And Ken, I'll bring you in here. How do you keep multiple drones so precisely in sync while managing a swinging load in midair?
Well, it all starts with the pedigree of the aircraft. So the Callisto 50 is we've been building this since 2019, and it's the reason for the company even being based off the initial success we had with it, which was from a Royal Australian Air Force Project Jericho project initially. Yeah, we had to carry a very particular lidar system, which was very expensive and rare and heavy. So from the success of that, when we did trials and evaluation with, well, it did two actual trials that we got it qualified for under CASA. We saw that it proved its mettle and it was able to do the job it was supposed to do, and we knew we were onto something special, and that led to other iterations to get to where we are now. And I think we sold our first proper production aircraft, I think about 18 months afterwards from that development course. But yes, you need this aircraft that has an overhead in thrust, like a very strong thrust authority. Leonard's the like global expert in this, but I'll try paraphrase it. Yeah, so it's got a lot of performance, which allows it then to and very tight position control. So it allows it to resist the movements of the coupling of the loads to get a very with a lot of authority. So it's really a combination of the strength of the chassis, the amount of thrust we have, and the precision of the control that allows us to stay in sync rather than wander around the air. And
Yeah.
it's not the same as it looks a bit like light show drones, but there's no penalty really for a light show drone being a little bit out of position, and it's very hard to see. But for ours, there's always a penalty.
And then behind the scenes, we are
Yeah.
directly linking that control system at a quite a intimate level, quite deep down in the controllers, to reduce the latency, the delay between multiple aircraft. And that's why if you've seen the videos of us doing, they are almost perfectly in sync.
They're
To the
incredible.
human eye,
Yeah.
you can't really see any delay.
So you've already secured a multi-million dollar defense contract. So what did that mean for the business? But also, what does it mean more broadly for Australia's role in the global drone race?
Well, this often comes back to the sovereign capability argument that's made. Like Australia's actually got a lot of pedigree in the drone industry. CASA was the first regulatory body to actually regulate drones back in 2002, so it's very forward looking. And that comes down to some of the nature of Australia being the tyranny of distance and the relatively small population. We've got to do more with less, or we're not going to be able to compete at all. Um, but yeah, like what this allows us to do here is with the fact that we're building it here ourselves and developing it here ourselves means that we can control it in circumstances like we've had recently with COVID, where you couldn't bring outside help in and expertise to do anything really. We've seen a lot of our customers complain that some of their systems are effectively grounded because they can't do anything with them. They've got some minor, or well, it could be minor, could be major. They don't know. They're unable to get help to evaluate what was wrong with their system. So having that expertise locally is critical to going to any sort of industrial process going forwards, and being able to secure um, contracts that you don't get hit up with liquidated damages or other penalty clauses if you're late on them, and really be able to secure any kind of future in operations. Because with our drone, there's over 1,500 parts, and it only takes like one, essentially, depending if it's a critical part, to prevent it from being flight worthy or operational at all.
So yeah, having that tight loop
Yeah,
with a local manufacturer allows companies to work much more confidently in an emergency in an emerging technology.
yeah.
When you're trying to talk across time zones and oceans, you know, when there's a problem, and most of the time it's human error, or just a lack of knowledge in a particular corner of the system. It's a flying robot. It's complicated. Being able to get on a phone straight away and know somebody's operating the same time zone, potentially across the other side, a few kilometers away in the state at times, it's gives companies the confidence to move forwards assertively, trying to implement these new technologies.
There's been a lot of history. I mean, a lot of our customers tell stories of being burned, where they've purchased particular assets, and over time they've run out of support. The company's gone under, or particular components not being built anymore. Like, you name it, there's lots of pitfalls to unfortunately wade into if you're in these scenarios.
Do you think there's a broader opportunity, guys, for Australia to become a leader in autonomous systems?
I think we already are.
Yeah, for sure.
We've always been. Uh, Australia has sort of had a reputation for a long time there as being the clever country. I don't know if that was a reputation we promoted ourselves, or whether it was actually one known around the world. But in UAVs and drones, that's definitely the case. Of uh, the senior developers of multi-rotor and fixed wing autopilot systems, a significant portion of them are based here in Australia. So, and I think, as Ken said, that's to do with our regulatory environment. It's due to our space, our weather. Um, yeah, it's already a central hub of the drone industry, and this allows us to actually stay in front of the leading edge development as well, as far as these things go.
Yeah, and we've seen recently as well that universities, well, ones I'm familiar with in Melbourne, have specific UAS or drone courses, unmanned or uncrewed aerial systems courses. So they're actually teaching now specifically for this industry, and learning the nuanced parts of it. Like, it's not the same as a traditional aviation or aeronautical degree course. There, you're dealing with batteries, high power battery systems, high current DC systems, a lot of computer IT type technology, and mobile phone type technology.
Mm. High levels of autonomy.
Yeah.
Let's touch on the business journey that you've both been on. Freespace is rare in that you've stayed bootstrapped and profitable from day one, which is quite the achievement. So how have you managed to do that in such an environment that is very capital intensive?
Well, I think one of our key advantages we've had right from the start, and it might not be true to say we were profitable from day one, because
Definitely not.
we're both engineers, and there was quite a few days there where we were simply working for free, and I think it's a lot easier for two engineers to start an engineering company than a and then learn the business, as opposed to somebody that really knows the business to start an engineering company, because the first thing they've got to do is go and try and find engineers. We were lucky enough to have two engineers that were willing to work for free. Um,
There you
And
go. Yes.
that's right. So that makes a big difference. So once so and our focus wasn't on promoting the business or building up clients. Our focus was on building a good product and finding only one or two clients that could use our particular product profitably, so that we were our client load was small, but our clients were making money using our aircraft and wanting to buy more. So we were immediately focusing on small numbers of clients, each trying to build a fleet rather than selling a large number of individual aircraft and then having a large support load. And so as that grew and we basically plowed all that profit back into developing the product and manufacturing, to a point where we actually started to feel like we're in a position where we could start doing all the classic things like actually building a website and advertising and promoting ourselves.
Yeah, and there was, I mean, to add to that as well, we we deliberately picked a very specific niche. We were working, I mean, I think by the time 2019, I had 7 years of building multi-rotors under my belt, and Leonard was probably more like 10. So we're quite familiar with the technology, even though it was emergent, and made a lot of mistakes and learned from those mistakes along the way. We picked this certain niche, which is like a heavy lift drone niche, which, the Callisto 50 is 52 kilos takeoff weight, but that niche kind of flows from 20 to 100 kilos, which is kind of where it is still, even 5 6 years later. And we decided very early on that we would stick in this classic CASA rule set, the entry level rule set. So visual line of sight under 400 feet, away from aerodromes. Otherwise, if you start relying on BV loss approvals and things, you've got to pay for them. They're not guaranteed. It's a lot more risky and onerous. So we deliberately, picked our battles and stuck with it.
We focused on doing what we could do extremely well rather than hoping for the best.
Yeah.
Sounds like common sense to me.
Yeah.
What's the range of the from A to B? We can carry a payload from this part to that part. What distance is that?
It's a it's a difficult question to answer because it depends on the payload. So you get diminishing return. There's a real sweet spot, like a bell curve, but you get diminishing returns if you go a lot heavier, and you get diminishing returns in the work you do if you go a lot lighter. So I think realistically, we can do, and this includes comms range and other sort of practical considerations, weather, but we can do 10 kilometers at full payload return very reliably. If you can push it out further to 15 or 20 kilometers, one way or with lighter payloads, but you're working against other factors then, like comms range, like weather, like overheads and batteries to return. So very nuanced question, but 20 kilometers is a very sort of far end sort of practical range. Yeah.
An interesting example of this was we were doing ship to shore operations, doing demonstrations, and in a single morning, without too much pressure, we moved about half a ton to and from a vessel parked about a kilometer offshore. So, yeah, the numbers add up quite a bit.
I bet they do.
Hmm.
And your proposition is materially compelling to an operator that would traditionally use a helicopter or some other aircraft to do it.
Yeah. One of our fundamental principles is to try and take helicopter pilots out of the dead man's curve. Low and slow, light payload, slow and slow. Helicopter pilots hate doing it. It's dangerous.
Mm.
So that's one of our core focuses is making that possible.
And so how do you divide your roles, gents? What does that look like, and what have you learnt about working together?
Well, Ken and I, we're as you say, we're both engineers, so we both started up focused on the engineering. I'm the pragmatist, Ken's the optimist as far as the engineering goes. And between the two, focusing on keeping it practical, but making it as taking that practicality as far as possible has been a happy tension between the two of us. Um, but as far as operating goes, again, it's something similar. Ken has spent a lot of time focusing on the regulatory environment and operating these aircraft in a professional in professional applications, industrial applications. Whereas I have a lot of experience actually making the aircraft fly in these various applications. And so we come together and overlap heavily in the middle. But that's how we sort of divide up that workload.
Yeah.
And it's
We've
about,
we've
nowadays, it's about training people to actually
yeah.
take over that, and making sure we've got a team of people underneath us that can take
Yeah, and
those roles.
we've pushed the boundaries with that. So as Leonard said, I mean, we've gotten BB loss approvals, and we've flown out to 15 kilometers range and back in a commercial mission a few years ago for surf lifesaving. We've flown from ground up to 10,000 feet and held a payload up there and came down. And these are all based on their privileges rather than guarantees as far as being awarded to you by CASA and DAS as well. We work with the Defence Aerospace.
Of
So, but
course.
this was built up success and um, yeah, like confidence that we'd be able to do what we said we do. That allowed us to open up our gambit for what we can do with the aircraft outside of the standard rule sets.
Yeah.
And
And
so looking ahead, so what's next? Where is this technology going? Is it in emergency services, emergency response, mining, defense?
I
What are
mean,
the possibilities?
if you think of the Olympic slogan, harder, faster, stronger, longer, it's pretty much, I mean, that's a good basis for where our customers want the technology to go. So yes, we're certainly concentrating on those three areas. Commercial enterprise is probably more than 50% of our market, and we see that as being a very, very strong long-term market. And when you think of that, that's heavy industry, really. It's mining, it's utilities, like Leonard mentioned, power line stringing. There'll be asset inspections and digital twinning with that as well. It's cargo logistics and mining, same thing, surveying. It's mineral exploration. It's renewable energy type operations like offshore wind farms. Um, and I think that's the main one. Oil and gas as well, obviously going to offshore platforms, doing dangerous, like the classic drone acronym. Dull, dirty, dangerous distance. It's staying working the dead man's curve, working awful weather, being places where humans just don't want to be. Either it's not good for us from a risk point of view, or it's just arduous, or remote, or whatever. Um, and then, like defense, we are working with Navy heavily, and it's mainly around logistics and ISR and surveying, where the aircraft is especially well adept. This ties into our ship ops technology, which I think Leonard just touched on, but ship ops was like the precursor to cooperative lift. We created a beacon that you could mount on a ship or any vehicle, really, but ship being the case here, and it allowed the aircraft to see ship as home and operate around the ship as if it was like a normal GPS coordinate and move with it. So it allowed autonomous operations to and from ships, very high degree of autonomy, very little pilot workload where it would be immensely difficult before. And then that built the pieces for cooperative lift. And then obviously emergency services are public sector or safety type work like search and rescue and disaster recovery, floods, fires, landslides, things like that.
Have we entered the age, do you think, gents, of the industrial flying robot?
I would say we're just opening the door to
The
that
iPhone
age.
moment is about to happen, I
Yeah.
think.
The technology, the technology is here, but the world is just starting to learn to use them, and starting to learn how to integrate them, and starting to understand where they can be used to save money or make money. Um, and so, yeah, I think over the next 5 to 10 years, we're going to see drones around our normal lives become a very common sight. Not so, and I'm not talking about the little DJI, selfie drones. I'm talking about large industrial applications. We'll see aircraft doing craning jobs and not notice because it's just something that you see commonly.
Yeah, and that was part of the reason why I was so confident to get into drone industry originally, is I'd seen something similar in my father's industry in mobile phones in the 90s, and saw how that emerged. And, just like once they took hold, like you can't imagine a world without mobile phones now.
Ken King and Leonard Hall from Freespace Operations, many thanks for joining us on the Unicorns today, and all the very best with the business.
Thanks for having us.